Welcome back to the Trending Tech Show, everyone. Today, we're diving into an exciting topic that's been making waves in the AI and language model community, chain of thought, or CoT. To help us unpack this, I'm joined by Mickey, an expert in natural language processing.
Thanks for having me, Alex. I'm really looking forward to breaking down chain of thought with you and your listeners.
Great. Let's start with the basics. What exactly is chain of thought prompting, and why has it become such a hot topic in the world of large language models?
Chain of thought prompting is essentially a technique used to improve how large language models reason through complex problems. Instead of just jumping straight to an answer, the model is guided to generate intermediate reasoning steps, kind of like thinking aloud. Imagine solving a math problem by explaining each step out loud instead of just blurting out the final number. This step-by-step reasoning helps the model mimic how humans tackle complex questions by breaking them down into manageable parts.
That sounds really intuitive. So instead of the model giving a quick answer, it works through the problem gradually, right?
Exactly. That gradual breakdown reduces the chance of errors because the model organizes its thought process, which is especially helpful for multi-step tasks like arithmetic or common sense reasoning. For example, instead of just saying 91 for 52 plus 39, the model might say 52 plus 30 is 82, then 82 plus 9 equals 91. This structure makes the reasoning transparent and easier to follow.
Interesting. How does this compare to how models normally work without chain of thought prompting?
Without CoT, the model usually tries to solve problems in a single step, which can result in mistakes when the problem is complex. The model doesn't explicitly break down how it arrives at the answer, so it's more like guesswork sometimes. Chain of thought helps produce answers with clear logical steps, improving accuracy, a big deal for tricky tasks.
You mentioned multi-step problems like arithmetic and common sense reasoning. Could you give some real-world examples or applications where this approach shines?
Absolutely. In education, for example, tutoring systems can use CoT reasoning to explain solutions to students step by step, making it easier to understand the problem-solving process. In customer support, transparent intermediate reasoning helps build trust, since customers can see how the AI arrived at a particular recommendation. Also, in complex question answering or legal decision support, where deductions need clear explanation, CoT methods are incredibly valuable.
Got it. So this isn't just an academic exercise. It actually impacts how we might interact with AI systems in meaningful ways. Now, I've heard there are different types of chain of thought prompting, like few shot, zero shot, and something called self-consistency. Can you explain these variants in a simple way?
Sure thing. Few-shot chain of thought means you provide the model with a few examples that show step-by-step reasoning in the prompt, kind of like giving it a mini tutorial so it can mimic that style. Zero-shot CoT is a bit different. You ask the model to think step by step without giving examples. This taps into the model's own ability to reason through the problem. Self-consistency takes that a step further by having the model generate multiple reasoning paths for the same problem and then picking the answer that appears most often. This approach averages out uncertainty and improves accuracy even more.
That's clever, asking the model to double-check itself in a way. What are some challenges or limitations with chain of thought prompting? Does having more steps ever introduce problems?
Great question. While CoT often improves accuracy, it can sometimes propagate errors if one reasoning step is flawed, leading to a wrong final answer. Also, longer reasoning chains mean longer outputs, which take more time and computational resources to generate. For simple tasks like 2 plus 2, using a long reasoning chain might be overkill and even introduce mistakes where a quick answer would suffice.
So it's about finding the balance between detailed reasoning and efficiency, depending on the task. How do researchers and developers manage these challenges?
They use several strategies. Fine-tuning models on datasets containing explicit reasoning steps helps the model internalize how to reason correctly. Another approach is integrating verifier models that score or check the reasoning steps, selecting the most reliable output. Sometimes, models can also revise or backtrack their own reasoning steps, a process called self-correction, though this is still an emerging capability.
Fascinating. You also mentioned tool integration earlier. What does that look like in practice?
In practice, models can be augmented with external calculators, APIs, or knowledge bases. So if a model is reasoning through a math problem, it can offload calculations to a specialized tool while focusing on logic. This reduces errors, especially factual or arithmetic ones, making the reasoning more grounded and trustworthy.
That definitely seems like a smart way to boost performance. How do researchers evaluate whether the chain of thought reasoning is actually good or reliable?
Evaluation involves multiple metrics. They look at the final answer's correctness. Does it match the expected result? They also assess the quality of each intermediate step, checking for logical consistency and relevance. Human evaluations often rate how clear and coherent the reasoning steps are. Additionally, researchers test robustness by seeing if small changes to a question lead to stable reasoning paths. Efficiency and faithfulness, meaning the reasoning reflects the model's internal process, are also important criteria.
It sounds like a lot of work goes into ensuring these models don't just reach the right answer, but do it in a way that's interpretable and trustworthy. Before we wrap up, what do you see as the future of chain of thought, prompting, and reasoning in AI?
The future is really exciting. We'll likely see more automated ways to generate reasoning examples, so prompt crafting requires less manual effort. Models might get better at self-correction and verification, leading to safer and more reliable AI. Integration with retrieval-augmented methods will help ground reasoning on factual data. Plus, we can expect applications to expand into scientific domains, complex decision-making, and multimodal tasks. Overall, chain of thought is pushing AI closer to human-like problem-solving and explanation.
That's an encouraging outlook. Thanks so much, Mickey, for making this complex topic so accessible and showing us the practical implications of chain of thought prompting.
My pleasure, Alex. It was great chatting with you and sharing this fascinating technology.
And thanks for tuning in to the Trending Tech Show. Today, thought prompting helps AI models break down problems step by step for better reasoning, transparency, and trust. While there are challenges like error propagation and computational cost, ongoing advancements like self-consistency and tool integrations are making CoT more powerful and practical. Until next time, keep thinking, step by step,